Hey guys, today we're going to talk about how to do our earthquake epicenter station lab and how to do the first page, which is our data. Let's first talk about the point of the whole lab, which is the map on the next page. The map on the next page looks something like this. So what it's showing us is that we have 3 stations. Station 1 right here, Station 2 right here, and Station 3 right here. All these 3 stations are receiving PNS waves from a certain earthquake, and all these 3 stations are trying to figure out how far away the earthquake is or exactly the location of the earthquake. What this map is showing us is that Station 1 already detected the PNS waves and calculated that the earthquake itself is somewhere this distance away from the epicenter, this distance away from Station 1, but it doesn't know exactly where the earthquake is. Station 1 just knows that the earthquake is somewhere around the circle this distance away from Station 1. So to figure out exactly where the earthquake is, we need data from Station 2 and Station 3. We need to figure out exactly how far away the earthquake is from these 2 stations to finally figure out exactly where the earthquake is. So let's get started. So on my first page, this data table is showing me that for Station 2, the P wave arrives at this time, the S wave arrives at this time, the difference in arrival is this time of the PNS wave is this. I just need to find the distance to the epicenter. For that, I'm going to be needing my reference table right here and a piece of scrap paper. Okay, so my difference in arrival time for my P and S wave is 2 minutes and 55 seconds. I'm going to go to my reference table and I'm going to mark 2 minutes and 55 seconds on my scrap paper. So as always, I'm going to align it with my y-axis. I'm going to mark a line at 0. And remember that my difference in arrival time is 2 minutes and 55 seconds. I'm going to mark a line at 2 minutes and 55 seconds, which should be somewhere over here. This is 2 minutes, 2 minutes 20 seconds, 2 minutes 40 seconds, 2 minutes 55 seconds. So now that I have my lines, I'm going to take my marks and I'm going to move it up my PNS wave curves and see where my curves match up or connect with the lines that I created. And it looks like they match up somewhere over here. So my marks are matching up with my P and S wave curves. Now I just need to look at my x-axis and see what distance that is, and this is my distance right here. This is 1,000, 1,200, 400, 600. This mark right here is 1,700 kilometers. So that must be my distance that my earthquake is from my Station 2. So my distance is 1,700 kilometers. Please pause this video and try this yourself before moving on. So now I know how far away the earthquake is from Station 2. We need to figure out how far away the earthquake is from Station 3. And to do that, first I need the arrival time of my P wave and the arrival time of my S wave. And I can figure that out using this seismogram that I have for Station 3. A seismogram is a drawing created by the seismograph, the device that we use to detect P and S waves. And it shows us when the P wave arrived and when the S wave arrived. So let's figure out when the P wave arrived first. Each big line is 1 minute on my scale, and each small line is 20 seconds. So that means this is 11 hours 40 minutes, 11 hours 40 minutes 20 seconds, 11 hours 40 minutes 40 seconds, and this must be 11 hours 41 minutes because 1 minute is 60 seconds. So my P wave must have arrived at 11 hours 41 minutes and 0 seconds. Now we just need to figure out when my S wave arrives. So we're gonna go back to this scale over here, and this is 11 hours 45 minutes, 11 hours 46 minutes, 11 hours 47 minutes, 11 hours 48 minutes, and this must be 11 hours 48 minutes and 10 seconds because each small line is 20 seconds. So my S wave arrived at 11 hours 48 minutes and 10 seconds. Okay, so now I know when my P wave arrived and when my S wave arrived. I just need to figure out the time difference. To do that, I'm gonna subtract the bigger number minus the smaller number. I'm gonna do that right here. 11 hours, 48 minutes, and 10 seconds minus 11 hours, 41 minutes, and 0 seconds gives me 0 hours, 7 minutes, and 10 seconds. And that's what I'm going to write down here. So my time difference is 7 minutes and 10 seconds. Now that I have my time difference, I can figure out the distance that my epicenter is from the station. And for that, I'm going to go back to my reference table and I'm going to use scrap paper. Okay, so let's mark 7 minutes and 10 seconds on my y-axis on my scrap paper. So always I'm going to mark a line at 0, and then 7 minutes and 10 seconds must be somewhere over here, because this is 7 minutes, this is 7 minutes 20 seconds, 7 minutes and 10 seconds must be somewhere in between. And I find that if I move this up, my marks connect with my P and S wave lines right over here. Okay, and I just now need to figure out how far away that is, what my distance is for that. And I'm gonna use my pen right here and just mark that right here. You don't have to mark it on your scrap paper, sorry, your reference table, but I like to do it. This distance is 5,000, 5,200, 400, 5,500 kilometers, and that must be my distance from the station to my earthquake epicenter. Pause this video, try out Station 3's data, and on the next video, we'll figure out how to do the map part. Thank you.